A good day to everyone who's watching. In our lesson today, we're going to talk about indices. Indices is the word in plural, and in singular, it's called an index. An index is the power of the base. For example, 2 power m, the m here is the index, and the 2 is the base. Then also the size of the index is a bit smaller than the size of the base. Now, we have the laws of indices, and they don't differ so much from the laws that we looked at in O-level. So the first one, multiplying numbers of the same base, we just add. That is, if it is 2 power 3, then times 2 power negative 1, that this one here, we keep the base and then we add the powers there, such that I have 2 power 2 finally. If it is division, we subtract. If we have 2 power 4, then into a power 2 again, that when you open the brackets, the powers are going to multiply each other there, and then we shall be having a 2 power 8. Now, the rest of the laws, we are going to employ them as we are doing our examples. Example 1, simplify the following expressions. Roman 1, we have 4 power 3 all over 2. Now, if I prime decompose 4, I'll be having 2 squared, and then there is a power of 3 all over 2 there. So when I open the bracket, the powers are going to multiply each other there. Then finally I'll be having 2 power 3. If the question was evaluate, you can give the answer as 8. But here they have told us to simplify, so I can leave my answer in index form. Roman 2, we have 2 all over 3, then power negative 3. First of all, I'm going to first make my power positive by taking the reciprocal of what is inside. That is, I'm using the last law of indices that I wrote. So this is 3 all over 2. Then now my power is positive. Then from there, I can open the bracket. The 3 is going to have a power of 3, and also the 2 is going to have the power of 2. So I can leave the answer there, or I can say that 3 cubed is the same as 27, then divide by 8 there. Roman 3, the 2, 4, 3 is appearing in the numerator and in the denominator, so it's dividing. Now I'm going to subtract its powers. So that is the 2, 4, 3, a half minus 4 all over 5. Then now 27 power a half times 2, 4, 3. When I subtract these fractions here in O-level, we used to get the LCM of the denominator. That is 10, multiply 10 there, multiply 10 there. So this one here gives you 5, then minus this one here gives you 8. You have negative 3 all over a 10. So power negative 3 all over a 10. Now the 27, when you prime decompose it, you'll be having 3 power 3 then times a half. Then the 2, 4, 3 is the same as 3 power 5, then times the negative 3 all over 10. So opening brackets, the powers are going to multiply each other. So that is 3, 3 all over 2, then times 3. When I multiply here, I'll be having negative 3 all over a 2. Now, multiplying numbers of the same base, you keep the base and add the powers. So this is 3 power 3 all over 2, then plus the negative 3 all over 2. And when you add them, you'll be having 3 power 0, which is 1. You can leave the answer there or give it as that, because here they told us to simplify, then there you are evaluating. We are still simplifying. Now we are upgrading to some examples that are a bit complex. So for this one, we are going to prime decompose the 8 and the 4. Then those in the numerator, we add the powers, and even those in the denominator, we shall add the powers. So the 8 is the same as 2 power 3, but we have a power there, n plus 2, then times the 2 power 2, the same as 4, then there is also another power outside there, then divide by 2 power n times 2 squared into n all over 2. Opening the brackets now, I'm having 2, 3 into n plus 2, then times the 2 into 2 minus 1, then divide by 2n there, then times the 2n all over the 2. In the numerator, I'm having my 2 power 3n plus 6, then plus this one here, that is 4n minus a 2. Then in the denominator, I'm having my 2n plus the n, because this 2 here is going to cancel, and then you have this 2 here, the base, to be having power n there. The powers of the numerator, when I add the n, I'm having 7n. Then the figures there, 6 minus 2, I'm having a positive 4. Divide by 2 power 2n. So we are going now to subtract the powers there. So this is 2 power 7n plus 4, then minus the 2n. Part B, here I'm having a bracket raised to a power and the same bracket raised to a power there. So I can first factorize out, because this bracket raised to some power, it is common, or I can get a multiplying factor both in the numerator and in the denominator. Now, when I factorize out the common figure there, which is x minus 2 raised to 3 all over 2. Remember, in indices, we said multiplying numbers of the same base, we keep the base and add the powers. So if I reopen this bracket, this times that, I'll keep that base, x minus 2, then the 3 all over 2, I add it to 1. So this 3 all over 2 plus 1 is the one that give me the base and that power there. Then I also multiply it there and I go back there. So that means that my x minus 2 power 3 all over 2 is the common factor. So now what is inside the bracket, any number power 1 is that number. So that is x minus 2, then plus 2 there. Then now this 2 cancels with that 2, and then I'll be having the x into the x minus 2 power 3 all over 2. So I can get a factor that I can multiply in this first term together with the second term there, but I multiply that in a way that it is a neutral one. I multiply it in the numerator and also multiply it in the denominator. So this is the neutral one I was talking about. I've multiplied it in the numerator and also in the denominator. The denominator of that expression, it was a 1. Now when I multiply, we say you keep the base, so the base is x minus 2, and then you add the powers. So power a half, adding it to 5 all over 2, we shall be having 6 all over 2, and that is power 3. Then plus the 2 into, when I multiply this times that, I'll keep the base, which is x minus 2, add the powers. A half, add it to 3 all over 2, I'll be having 4 all over 2, which is a 2. Then divide by my x minus 2 power a half there. Now in the numerator, you see that the x minus 2 squared is common. So if it is common, then here I'll be left with x minus 2, then here I'll be left with a 2 just. Then divide by the x minus a 2 power a half there. So this bracket is like the bracket we had here. Now I just need to cancel out the positive and the negative 2. Then I'll be having the x left out in this bracket here. Then these ones which are dividing each other, you keep the base, you subtract the powers. So we shall be having x into x minus 2, then power 2 minus a half. So 2 minus a half is the one that gives us 3 all over 2, and then we come back to this answer here. So the either way you think of is what you can do, because in math there are very many alternatives. Part C there, it is just like the former part B. You have so many alternatives there, but what we're going to do is to first simplify that part there, making the power to have a positive index, or you can get a multiplying factor and then you multiply it in the numerator and in the denominator. So using the first alternative, this is 1 plus x power a half there, then minus x all over the 2 into 1 plus x power positive a half, then divide by 1 plus x. The numerator now, it is also having a fraction. When you deal with that fraction in the numerator, getting the LCM here, it is 2 into x plus 1 power a half. So I need to multiply it there, also multiply it there. So that is my 2 into 1 plus x power a half. So when I multiply it here, I'll be having 2 1 plus x power a half into 1 plus x power a half, then minus, here I'll be left with x, then divide by 1 plus x there. Now, here multiplying numbers of the same base, you keep the base, then you add the powers. So a half plus a half, that one gives you a 1. So this becomes 2 into 1 plus x power 1, then minus the x there, then divide by 2 into 1 plus x, then power a half. And now this is times 1 all over 1 plus x. This one is power 1. So here, when I open the bracket, I'll be having 2 and then 2x. But when I subtract that, I'll be having 2 plus x. Then divide by 2 into 1 plus x power a half into the 1 all over 1 plus x power 1. So in the denominator, this times that, it's the one that is going to give us keeping the base of 1 plus x. Then you add those powers, 1 plus a half. So this is going to be 2 plus x, then divide by 2 into 1 plus x. When you add a half to 1, you'll be having 3 all over a 2 there. So I have simplified this expression. The second alternative, you can get 1 plus x power a half. You multiply it in the numerator and also in the denominator there. So this is 1 plus x power a half, then minus x all over 2 into 1 plus x power negative a half, then divide by 1 plus x, and this one is power 1. So when you open brackets for the numerator, this times that, you see that the base is the same, you keep it. Adding the powers, you see that that one is going to give you a 1, the base power 1. Then you multiply this times that, you see that when you add the powers, you'll be having the base raised to a 0. And then you multiply this in the denominator. So I'm leaving this for you to complete using this alternative and see if we get the same answer. So we are ending our lesson here with an exercise, but please, you try out these numbers and get other numbers of the same kind and try them out. Like I said, in A level, you as a student, you must contribute 70% and the teacher contributes 30%. So you can go to the reference books. For example, in Pure Math by Backhouse, book 1, you can go under the chapter of useful topics in algebra. That's when you are going to find the indices, logarithms, and the surds there.